Number 1, the function g is defined as follows. Part A, use a table of values to estimate the limit as x approaches 2 of g, accurate to 3 decimal places. Show the work that leads to your conclusion. To use a table of values, we need to make an x, and instead of y, I'm going to put g there. And we need to get closer to 2 from the left, so I'm going to use 1.9, 1.99, and 1.999. I'm now going to put a little squiggly for 2. And then after that, I'm going to use 2.001, 2.01, and 2.1. All right, and then from here, if I plugged 1.9 into that function, I would actually put this on my calculator and use the table feature of my calculator. When I do that, I should get 0.48718. When I plug in 1.99, I'll get 0.49875, and when I plug in 1.999, I'll get 0.499987. Coming in from the other side, if I plug this in, it should be 0.50012, and then 0.50125, and then 0.5122. All right, then to find the limit, we're going to look at what's happening as I'm coming in from the left. I notice that my y values are getting closer and closer to 0.500. And then from the right side, I do also notice that my values are getting closer to 0.500. So since my limit from the left equals the limit from the right, my limit will equal 0.500. All right, then it says to find the limit analytically. Analytically means algebraically. So first thing that I'm going to try to do is always just plug 2 in and see if we can get an answer. So if I plug 2 in, I'll get 4 minus 4 over 4 minus 4, which gives me 0 over 0, which means I cannot calculate it that way, so I need to come up with another method. I do notice that I can factor, so I'm going to factor out an x in the numerator. That will leave me with x minus 2, and down below I can factor that into x plus 2 times x minus 2. And I do notice that my x minus 2's can cancel, so I'm left with x over x plus 2. And now my last step would be actually to plug 2 in for the x's. So I'll get 2 over 4, which reduces to 1/2. And notice either method I used, I still got the same answer. All right, showing that g of x is discontinuous at x equals -2, and it says to use the conditions of continuity to support your conclusion. There are 3 conditions for continuity. Number 1 would be that g of -2 is defined. Number 2 would be that the limit as x approaches -2 exists. And then the third condition would be that g of -2 is equal to that limit. All right, and if we want to show something as discontinuous, we only need to show one of them. And I think I'm going to stick with number 1, g of -2 being defined. That would mean that if I plugged in -2, I would be able to get an answer. And I notice that if I come up here and plug -2 in, that will make the denominator equal 0, and that would not be a defined answer. So I can say right here that g of x is discontinuous because g of -2 is not defined. And if I wanted to say something about, I noticed on this problem when I calculated it analytically that x equals -2 is a non-removable discontinuity, that would definitely show me that g of -2 is not defined.